Are we starting? Are we on, Belen?
Yes.
Okay.
Yes,
so let me start.
Marjolaine, you can start.
Thank you. Good day, good morning, good evening to all of you, and thank you for joining us today at the third Boundary System Task Team webinar on modeling and observing aspects of the boundary systems. And I'd like to thank today our guests, Dr. Eitaro Oka and Dr. Yasumasa Miyazawa, who will discuss with us on modeling and observing aspects of the Kuroshio system. And we also have today together with us Dr. Belen Martin Miguez from the OPC Secretariat, Dr. Kiyoshi Tanaka and Dr. Xinyu Guo, who are part of the Boundary System Task Team. So welcome and thank you for joining us. And my name is Marjolaine Krug. I'm a physical oceanographer and I'm talking to you today from Cape Town in South Africa. I'm the chair of the Boundary System Task Team. So I'll be moderating this webinar with the support of my colleagues. And just a few brief words about what we are trying to do. The Boundary System Task Team is an initiative led by the Goose Ocean Observation for Physics and Climate Panel, which is the OPC. And the main objective of the Boundary System Task Team is to provide guidance for both existing and planned sustained observing system at ocean boundaries. So in this webinar, what we want to do is to learn from mature systems who have already a well-established observing system and modeling community. And we also want to promote interaction between ocean and modeling communities and work together towards the co-design of the observing system at boundaries so that we can improve the value chain and improve how the model simulations represent the ocean and have greater societal impact. So before we start, I'd just like to explain the format quickly. So after my introduction, we'll have each presenter give us a brief overview of their presentation that hopefully you've been able to view already. And this will be followed by a discussion with questions both from the Boundary System Task Team that we've prepared, but also from you, the audience. So please just submit your questions through the question chat box. And we'll do our best to go through each of them within the time frame of this meeting. So yes, thanks again. And we will get started. I will let Kiyoshi introduce the first speaker. Thanks.
Hi, my name is Kiyoshi Tanaka, physical oceanographer. First, I'd like to introduce Eitaro Oka. Eitaro is a physical oceanographer. His specialty is the Kuroshio and Kuroshio extension current, especially utilizing ship observation and alga float. Actually, Eitaro was my classmate in a junior high school. We went to different universities, but by chance, we are now working towards the same goal. I'm happy to introduce him here. Hi, Eitaro, would you start your talk?
Thank you, Tanaka-san. We are actually high school teammates, so classmates, so it's kind of embarrassing. Yeah. So let me share my slide. How can I? Now, can you see my slide?
Yes, thank you.
Yes, I hope you can now see my slides. So I just briefly review my observation part for 5 minutes about the Kuroshio. So as all of you know, that Kuroshio is a western boundary current of the North Pacific subtropical gyre. It's bifurcated from the North Equatorial Current and flows East China Sea here. And oops, sorry, I cannot remove the Go webinar. Okay. in the southern coast of Japan, the Kuroshio sometimes flows along the coast, sometimes flows offshore. So this is characterized by bimodal path between large meander and the non-large meander path. And the large meander path occurred frequently during the late 1970s and during the 80s, and also in recent years. And in the downstream region, Kuroshio becomes Kuroshio extension, which is a free jet flowing over the deep sea floor with large mesoscale variability. And during the 1980s, when we didn't have satellite altimetry sea surface height data, the Kuroshio path variability was examined using tide gauge data along the southern coast of Japan and also on some islands of Japan. For example, whether the Kuroshio takes a large meander path or non-large meander path is well monitored by the sea level differences between the Kushimoto and Uragami number 6 and 7 here, which are only 15 kilometers apart, but the sea level differences is low when the Kuroshio has a non-large meander, large meander path, something like that. So using these tide gauge data, the transition processes among 3 typical paths of the Kuroshio was examined. And since during the 90s, we have had satellite altimetry sea surface height data, and the path variations has been examined using these sea surface height data, and the research target shifted gradually from the Kuroshio to the Kuroshio extension, partly because the Kuroshio large meander did not occur after 1991 for more than almost 25 years until recently. And such cross extension studies was led by Bochu, who found the pronounced Kuroshio extension decadal variability between stable and unstable states. And this decadal variability is produced by a remote wind forcing in the central North Pacific related to PDO, and the cross extension index is well correspond well with the PDO index with a time lag of 3 to 4 years, a time needed for the Rossby wave propagation. And such historical researches using tide gauge data or satellite data are supported by shipboard repeat hydrographic sections by Japanese governmental agencies. The representative one is the 137° east section across the Western North Pacific, which has been maintained by the Japan Meteorological Agency for more than 50 years. And the JMA also has a number of repeat hydrographic sections across the Kuroshio, and also other agencies. For example, the Japan Coast Guard used to maintain a 144° east line here for 30 years. And also the Japan Fisheries Agency has been maintaining O-line here for 20 years. And the Japan Fisheries Agency and the Prefecture Fisheries Research Institute has also maintained coastal, very high dense hydrographic sections. And these data are used mainly for the forecasting models for the predictions. We have also other observations, such as the surface monitoring using wave gliders by the Japan Coast Guards since 5 years ago around the East China Sea and the Japan Sea. We have only one HF radar for the Kuroshio operated by Miyazaki Prefecture, but we have almost no glider for operational observations in Japan due to some unique reason for Japan. And the biggest one is that we have too many fishing nets around the Japanese coast, so which makes it hard for the deployment and the recovery of gliders. I think that's just 5 minutes, and I stop here. Thank you.
Okay, maybe
Thank you very much, Eitaro. Yeah,
please.
I will introduce the next speaker now.
Yeah, so let me introduce Miyazawa-san now. And actually, I'm Shin Yuko and works in Japan, but I Actually, I'm not, high school classmate with Miyazawa-san. Okay, but actually, about 20 years ago, we worked, together as at the same project. After that, I moved to a university, but Miyazawa still keep, in that project and actually become leader of GCOP since that time. And he has spent almost 20 years for this forecast system. So I think you have listened. You have seen so many information from his, talk. I think now he will give 5 minutes to introduce about his talks. Yes. So please, Miyazawa, please.
Thank you for kind introduction. Yeah, we are not high school friend, but just like high school friend now we have already enjoyed the 20, 30 years research together. Okay, let's move to summarize my presentations. I have summarized the research activities surrounding the modeling research targeting the Kuroshio. First, I have briefly mentioned the Kuroshio dynamics in terms of the view of the observation and modeling. And second, I have explained the roles of the operational modeling in understanding the Kuroshio dynamics. And third, I have explained, presented now major 3 agency doing operational Kuroshio prediction effort, and also I have pointed out some notable issues of the Kuroshio observing system, focusing the geostationary satellite and a very dense network managed by the local fishery agencies. Now, finally, I emphasize possible communication with stakeholder towards further improvement of both observation and modeling systems. I just briefly read my summaries. Using the model methods, the dynamics of the Kuroshio has been investigated mainly from the 2 views, forced and internal mechanisms. Both mechanisms are important. For investigating the internal mechanisms, operational ocean data assimilation system could be utilized for investigating the effect of the initial conditions representing the eddy distribution on the resulting evolution of the model dynamics. I have shown some typical examples. And I think the major limitation of the model scheme at the present time is representation of the air-sea interactions, maybe representation of the air-sea flux and the resulting dissipation, and turbulence scheme could have more improvement, maybe utilize more and more observations. Some of Japanese oceanographer groups are constructing the feedback system connecting the modeling and observation toward enhancing the observations, especially for the coastal areas. And also, I emphasize we need not only enhancing the observation system, but also improving the data assimilation system and model schemes because of sensitivity to the each observation could have the significant system observations, as shown in my final slide. Okay, I believe to emphasize possible activities toward enhancement of the coastal observation. Today, I will show one typical examples. My collaborator of the Miyazaki Prefecture Fishery Research Agencies provided this kind of small mobile CTD to the fishermen, that they have asked the fishermen to observe each point around their targeting fisher places. This slide compares the distribution of the in-situ temperature and satellite SSHA and satellite SSTs. The left figure shows the distribution of the in-situ observation point during the target period. Gray point shows the usual observation point managed by fishery local agency or other governmental agencies. The orange color point shows locations of the fisherman observation point. I have assimilated fisherman CTD data to checking the possible impact of the fisherman data. The upper panel shows model result with assimilation of the in-situ data, but without fisherman CTD data. The lower panel figure shows the assimilation result with of the fisherman CTDs. Okay, left panel shows sea surface temperature. Basically no difference, but if we are checking the subsurface conditions, for example, 50-meter temperature distribution shows some differences. If we assimilating the fisherman CTD data, assimilation results shows a more clear, warm streamers, maybe never represented by the usual observation network. This is just a small example. That's all. Thank you.
Okay, thank you.
You
So
very
I
much.
Think,
Let's start with the first question that will be asked by one of our ESTT member.
Yes. From Kiyoshi, I like to ask the first question to Eitaro. Okay. As you mentioned, sustainable observation of the Kuroshio has been conducted by some administrative agencies such as JMA, Japan Meteorological Agency, JFA, Japan Fisheries Agency, JCG, Japan Coast Guard, and local government. So my question is there much interaction among these agencies? Do you have some information?
So you mentioned you're asking about the shipboard observation, right?
Yes.
Okay.
My main interest is ship observation, but not limited to the ship observation.
Okay. So yeah, in Japan we have a long history of shipboard and other observations by governmental agencies. Yeah, as you mentioned. But basically, these agencies have been conducting observations for their respective administrative purposes. So, for example, it's interesting that when Japan Meteorological Agency strengthened their shipboard observation in 1972, the target was pollution, not the physical oceanography. So that's why, can I share my slide, Belen? If I cannot, that's okay. Yeah. Okay, so.
You should now.
Yeah, thank you. So there's, yeah, in 1972, they enhanced their observations greatly to examine the pollution around in the seas around Japan. So that's why many hydrographic lines name are begin with the P, which is means the pollution. So PN is pollution Nagasaki, yeah, and pollution Tokyo, pollution Kobe, something like that. And now the JMA, Japan Meteorological Agency, is conducting the observations for the estimating the budget of greenhouse gases. Also, the Japan Fisheries Agency, they are doing their physical oceanographic observations basically for the assessment of coastal resources. And as I shown, they have the high dense coastal sections by prefectural fisheries research institutes, and these are basically for the these sections are determined and modified in accordance with the target fish species and their temporal variations related to climate observations. so that they have own purposes, atmospheric purposes. So these agencies exchange information on their observation on a regular basis, but I think they don't arrange the observation together. But maybe it's a good time in Japan, it's maybe a good time for the construct a system like a Japanese goose or a juice. Yeah, because we now in a unit decade of ocean. Yeah, that's my answer.
Thank you. I agree with you, Juice.
Juice. Yeah.
Okay, so can I ask a second question? I mean, actually, I know Jacob used Princeton Ocean model. The base is this one, and my student also. Sometimes when I introduce Jacob, the people also ask me, why are you still using this old-fashioned model? Now ROMS is become more and more popular, and also MIT GSM and other things. So I would want to ask Miyazawa-san, and what's your comments on this question?
Very interesting question. This is we are still using Princeton Ocean model, but now our version of the Princeton Ocean model includes so significant improvement. For example, including the efficiency for massive parallelization or scheme improvement. Now our Jacob model is a little bit different from the original version of the Princeton model. But anyway, before 20 years ago, we have initiated our model research using respected Princeton Ocean model. Now we keep our lab to the Princeton Ocean models.
Okay, thank you. Yeah.
Thanks. I think we can start maybe asking questions from the audience. There's a question that's been asked by Dr. Neil Malan, who's a ex-colleague of mine in a way from South Africa, but he's now in Australia. So it's nice to see him on the chat. And it's something you mentioned, it's addressed really for both of you, I suppose. It was mentioned during your presentation that the resolution of AC fluxes is a big issue to improve the modeling, and that observations of these processes are needed. So the question from Neil is, what do you see as the way forward for improving AC flux observation? And I will ask Eitaro first to answer. Maybe Professor Yasumasa, if you want to input, you're welcome to after Eitaro.
So yeah, for the AC flux measurements, probably the biggest improvement in recent years is probably the satellite, high resolution satellite measurements, as I explained in the 20 minutes presentation. But I think we still don't have enough wave gliders nor marine buoy like Kyo around Japan. So that's a big theme, yeah, for the near future, yeah. So, and also now the wave gliders by the Japan Coast Guard that I mentioned was mainly operated for the administrative purposes. So the main target or main mission of the Japan Coast Guard is for the navigation safety. So that these measurements are made for the draw how to say tide. They are observing tide for the nautical charts, or they collect measurement meteorological or oceanographic data for the navigator or fisherman or so. So we have to consider how we can use these data for the research in real time. Yeah. So I think, yeah, this webinar gives me a good opportunity to consider about such topics. Thank you. Yeah.
Yeah, I also agree to more enhanced observation of the air-sea interaction, and the resulting subsurface process could be really required for model improvement. But now ongoing Japanese project named by Hotspot 2 planning to cover some part of the this air-sea interaction and related processes. I hope now ongoing Hotspot 2 could partly cover these fundamental issues.
Can I add some words?
Thanks very much. Yes.
Yeah. I'm involved in the Hotspot 2 project mentioned by Miyazawa-san. But such research project is usually lasts only for 5 years. So it's a big problem that how we can maintain for more than 5 years, make it sustainable. So that's the point. So in Japan, the research project is also always time limited. So the point is how we can move these observations to the observations by the government agencies. Yeah, that's the point. Thank you.
So following this topic, actually, I just wonder, want to ask Miyazawa, do you have some plan to do some AS coupling for the forecast system, like for Kuroshio or something, like coupling model or something?
Yeah, interesting issues. Now, one of our colleague developing a regional air-sea coupling system targeting the ocean current effect. Maybe we can show, near future, we can show some result based on this new coupling systems.
Okay, thank you.
Can I comment a little bit? Okay. About the air-sea flux condition, I like to emphasize the local weather condition because the local weather condition is very important for the coastal circulation that they interact with the Kuroshio or boundary current. However, the latest satellite cannot resolve the local weather condition, very high resolution. So in future, I think the very high resolution weather condition observation may be important. I think that's my comment. Thank you.
Thanks very much. Yeah, very interesting. And I was wondering about Eitaro, you mentioned that you have a SE flux buoy and about the impact of such observation in improving the representation of SE processes. But I will move to another question from the audience, which is sort of related. It is addressed to Professor Miyazawa, and it's from Yusuke Fuji. Sorry if I don't pronounce it perfectly. Saying it's very effective and important to show the observation impacts in ocean predictions to the people who take the observation data. On the mobile CTD case, how do you inform the observation impacts to the fishery people, and how did they anticipate the observation impacts? And I think that's really a key question, and more generally about demonstrating the value of the observation to the people who make these observations, but also to the users. So I would like to ask you to please, if you can please just answer that question from Yusuke. Thank you for asking that question.
Okay, thank you for raising the very interesting issues, important issues. Maybe we can demonstrate usability of our forecast information to each fisherman by providing our forecast information. Then ask each fisherman to please observe your ocean by yourself, and if possibly, please transfer your observation data to the forecast center like us. Then again, we are assimilating their fisherman data into our system. Maybe then we demonstrate skill improvement by assimilating fisherman data, and maybe fisherman directly could have received the impact of the observation by checking skill by themselves. Yeah, maybe this kind of feedback system could be developed.
Thanks very much. Yes, so there's a similarly related question by Dr. Ramasamy Venkatesan, who asking how the fishermen are using their CTD data. But so what type of fences are used by the fishermen, CTD, and how do they use the CTD data? If you can maybe respond to that, one of you, I don't know who is best placed there.
Sorry, again, please repeat again questions. I cannot understand.
Okay, the question is asking what sensors are on the CTD that the fishermen use, and how do they use their CTD data?
Okay.
Are they? I suppose maybe asking if there's they just use it when they go fishing, or do they have pre-planned?
Yeah, something like fishing. Something like fishing. The mobile CTD is a very small and very portable one. They are using the fishing actions, then automatically intruding into the ocean, and very easily pick up mobile CTDs. They're very easy. Yeah.
It was interesting when you mentioned, sorry, about the CTD data being taken by the fishermen and then used by you. I suppose
yes.
this means that you have. I suppose this means that you have data centers dedicated to receiving data from the fishermen. I mean, how is that data shared across the different people in the system?
Okay, this is just a result of the private collaboration. Some limited user just assimilated the data. Maybe more organizations achieving the operational transfer of such kind of data to the global telecommunication system could be required. More and more organization is required for achieving the more stable, more effective systems.
Okay, do Kiyoshi and Xingyu, you've got questions, more questions you want to ask? And I'd like to remind the audience, please don't hesitate to put your questions on the chat.
Yes. Okay. Please go ahead.
I just say one question in chat. So how is the choice of the transect from the Fisheries instrument motivated? What motivates such high resolution? So maybe some people can answer this one. I just wondering.
Okay, why high resolutions?
Yeah, you can see this from this question from chat actually. The fisheries observation is very fine. The resolution around Japan.
Maybe depending on the request from the local fisherman, or
yeah. So the idea is, what is the strategy behind that motivates this type of observation? Is it purely driven by the fisheries? I mean, you get a sense that there's such good. It's actually a question maybe more addressed to Eitaro, because there's such high resolution, and how much of these transects are repeated and sustained, and how much is just ad hoc observations?
This observation system is managed by local fishery research agency, but financial support comes from government. Maybe government could have a rigid policy to maintain this system, but I'm not so sure about. Maybe related to the fishery governance. Yeah. Actually, now government supported by the governmental budget.
So as I mentioned, basically I don't know the details, but I guess that these coast of shipboard observations are usually maintained targeting specific fish species. And anyway, they do not only the fisheries measurements, but also the physical oceanographic measurements as a basic information. That's why that's how the data are collected. So basically, as I mentioned, the hydrographic lines are set correspond to the distribution of the fish species, because probably each fisheries institute have its own target fish species. Yeah, squid or whatever. Yeah.
I think, roughly speaking, the Japanese people like especially the fish food. So abundant, much more fishes are needed than the other countries. So roughly speaking, this is my idea.
Yeah,
Yes,
the idea is
does
really,
seem
yeah.
to be a
Sorry.
major driver. Yes, actually, I would like to let put forward a question by Vyacheslav Lobanov about this data that's collected by the fishermen. And the one point is that, you know, if the fishermen are doing all these observations really solely for their purpose, there must be some kind of bias in the observation. And he's asking, if the fishermen activity is seasonal, will you get less information in winter compared to summer?
Yeah. Depending on the target fishes, maybe target fish could have a very seasonal dependence. Sometimes fishermen observed some specific fish for some specific seasons. Maybe depending on the target fishes, could have a seasonal dependence.
Thanks. It's quite interesting. It seems like maybe there's a lot of observations taken, but maybe some lack of coordination between the different people involved. And that prompts me to a question that I would like to ask Eitaro about the wave gliders development by the Coast Guards, if I remember correctly. So what motivated the deployment of these wave gliders, and how has that data been used by the community?
Yes. So they started these measurements since only five years ago after the oh, sorry, I am not sharing my slide. So can I think I'm not sharing my slide, right?
Yes, you are.
Yeah. So they have started the wave glide observation since only 5 years ago. So it's just began. Yeah. So before that, they are doing hydrographic observations along the 144 degrees line, but they turn it into wave glide observation. So these are, yeah, basically, as I repeat that these are the usually for the administrative purposes. So for the maritime safety. So the data are public open on their website, and probably the fishermen and the navigators are using these data and watching data. But these observations are not dense, nor these data are currently not sent to GTS. So yeah, that's the point. Yeah. So the point is that how these data will be made available to more people to use for the research purposes more easily. But yeah, this has a, how to say, great possibility in the future, because we have only one Kyobui southeast of Japan here for the air sea flux measurements. So these wave glider measurements can complement the Kyo observation and enhance the air sea flux observation or whatever around Japan. Yeah.
Thank you. I've got a question that actually comes from Janet Pringle, who unfortunately could not attend today, about the different users of the observing system, and do you have any involvement from the private sector? Do you have a sense of how much the private sector uses your observation, and then do they contribute to the system financially?
So I think for the shipboard data themselves are mostly used by scientists, but the data, especially the coastal data, are used in forecasting systems. So both the JMA and the Japan Fisheries Agency has forecasting systems, and they exchange data between them. And this forecast data used for so now they are providing very high resolution forecast system around the coast. So whose resolution is, I think, 10 kilometer or 2 kilometer or something like that. So they are open and used for probably used by many private sectors, fishermen or navigator. Also, the data are used for the long-time forecast, so it's probably used by, for example, beer company or yeah. So indirectly, they should be used by many private sectors, but not. I guess not so much usage by the data themselves. How about you, Miyazawa-san?
Yeah. Now, regarding the prediction ocean focus data, maybe focus data is open to private sectors. Now many private companies are utilizing prediction data, I guess.
Yes, I think, yeah, that's always the issue about how do we actually keep tabs of who's using the system in order to motivate for this observation to be sustained into the future. All right, I'd like to move on to another question that actually came from Lisa Bill. And she's wondering about what next, what's the future looking like for the Kuroshio, and which parameters or climate variables are observed well and which ones are not.
Mm-hmm. Yeah, so
that's for Eitaro.
Yeah, so as I mentioned repeatedly, the open ocean measurements are sustained by government agencies, so it's not easy to expand these observations because of the budget limit. Yeah, so my opinion is that the next generation, there should be more and more coastal observations like ones introduced by Miyazawa-san. So yeah, if we produce more easier and low-cost observation instruments, such activities, cooperative activities between scientists and, for example, fishermen, will expand. So probably in the next decade or so, such coastal observation will be expanded. That's my expectation. Yeah.
Yeah, this activity could be some kind of a flagship project memorizing coming ocean decade.
Yes, talking about projects, there was a comment in the chat about, I don't know if you are aware, this is really addressed to Yasumasa, but the Oasis project, which will look at AC fluxes. So there was just a mention that you should maybe engage with them in terms of AC observation if you're interested. And it's led by Megan Cronin of the NOAA. Yes, so I've kind of lost my thoughts here, but any other question that wants to come from the boundary system task team? There was something on the coordination between the different modeling components, because you have a lot of models that are operating at the same resolution, but we don't really get a sense of if you are working together with the other people who are building those models, and how do you
I missed some words from.
Yeah, I miss your word. Yeah.
Yasumasa.
Please,
yes,
please.
I
miss your word.
Between the different. Okay, sorry. I'll repeat the question. So you have a lot of different models at similar resolutions, and how do the different groups running these models interact?
Yeah, historically, each agency could have the specific targeting of their forecast system. For example, JMA has targeted the coastal disaster preventions. Maybe the forecast information should be used for early warning of the abnormal sea level tide or storm surge. And also, Fisheries Research Agency has their own users, including the local fishery agencies or fishermen themselves. JAMSTEC has just aimed at research of the ocean current dynamics, but recently we have expanded the target by including the social applications. But now we all observe. Three agencies have some collaboration for possible planning of the next generation satellite observation. For example, wide swaths named by Compila, something like SWOT. Now, basically, we are collaborating for planning of the next generation observation system based on the our focus product.
Yes, that's really interesting. So that's one effort of how the modeling community can help to build a better observing system. Are you involved in other projects on this, and how would you recommend in general to use the modeling to help the people doing the observations make a more streamlined observing system? Planning to run OC experiments, for example, or are you working with groups? Yes, if you can expand on this a little bit, please.
Okay, just following you, I mean, your description. So Miyazawa-san, you mentioned some social application. So I just wonder, can you tell us some detail about you planning or what you are doing for this issue? I mean, like a feedback for this forecast product to the social. What is social needs for this one actually? I'm wondering.
First of all, now our product is utilized by the ship navigations. They are utilizing our forecast to optimum design of the ship navigation route. Sometimes they are utilizing the Kuroshio current by saving their fuels. And our information is utilized by the design of the ocean renewable energy plant.
Thanks. I've got a question from Hiroaki Saito about which can actually be addressed to both of you, but I think it might be directed more to Yasumasa about the value of the observation. So I'll read the question. For further engagement with fishers and VOS, it may need to improve value of observation by preparing easy-to-use products such as fisheries forecasting model, and increasing the users may encourage government to continue to support monitoring and observation. Do you have any idea on how to improve the value of the observation for the general public?
Now, some institutions, including us, are developing the observation system experiment technologies. Now, using these technologies, we can suggest where should be observed and where should be more effectively observed by changing the location of the observations. Maybe forecast information could be more utilized for optimum design of the observations.
So I'd like to ask the data. So essentially, you're providing data, but are there other companies or industry that use your data to generate value-added products. For example, to add to this data something really specific to industry, or is this really just used by government and fisheries, and not quite, the information from the data is not quite transformed so that the users can directly use it as a product. For example, one example would be ship routing, like you said. Do you have a product that you yourself generate, or that some other companies generate from your products? Or do you just provide the data and then people do what they can with it?
I don't know. Do you guys know private companies who directly use the oceanographic data? Other than
yeah. I know
ship companies.
Private companies developing the specific applications utilizing, for example, ocean forecast data for providing the optimum ship routing. Maybe more application could be developed by other private company by further utilizing the forecast information.
Yes, it's one of the things that we're trying to do in South Africa is we don't have a system like as sophisticated as you have, or well-established system, but I think this link to the stakeholders is very important. For example, one product that we provide is alerts for red tides. So it's based on the monitoring of the chlorophyll, which is done routinely by the scientists, but with a little bit extra work, so that you can say exactly this is where the red tide is. This is our, and I think this might be a key aspect to consider when trying to motivate for the observation to be sustained. In a way, that's kind of the missing link at the moment in many of the observing systems.
So you're right. So today I limited my talk to the physical oceanographic part. So if we expand it to the biological and chemical oceanography, so there should be more and more demand from the public. It's obvious. But as for the I only talk about the physical oceanography portion. So
Thanks. So when you design the observing system for the physical oceanography, do you also interact with the communities from ocean biology and biochemistry to plan the deployment of assets?
That's a good question, Pro. So basically, for example, the shipboard measurements by Fisheries Agency, so their priority must be fish. So the fish came first, then the physical oceanographic parameters are measured together, something like that. So but for the GMA part, so they are now doing for the greenhouse gas budget. So the chemicals might be comes first, but it's the physical also. So it really depends on the institute or agency that that are conducting observations. So the really situation are different among agencies. That's the characteristics to Japan.
Now,
yes, it's very interesting. Thank you. Please,
Now we are developing the biogeochemical ocean modeling system based on our ocean focus product. Maybe eventually we will provide some information of our biogeochemical modeling result to more other users, including the biochemical oceanographer or related stakeholders. Maybe we will have more and more interactions with biogeochemical sectors.
Miyazawa-san are now utilizing the biologging. How about biologging? You not only gave the information data to biochemically, but also you get from the information from the biologist via the biologging data. Probably, I think it is important.
Yeah, I definitely agree. No.
So that's interesting. Dr. Yasumasa, are you using the biologging from the animals for your models?
Yes, yeah, we have assimilated the biologging data. Yeah, but now some biologist group is planning to organizing the observation effort to make possible their data transfer to the global telecommunication systems. In this case, more biologging observation is more utilized for the more other people by directly connected to the GTS, global telecommunication systems. Yeah.
Thanks. I think I'm just going to end up with one last question for Eitaro. How would you say that the observing system will look into the future for the Kuroshio? How is it going to evolve?
How is it? Sorry.
How is the observing system, how will it evolve in the future? What is the futuristic Kuroshio observing system looking like?
Yeah, so as I mentioned earlier, so maybe it's not easy to expand the budget, but probably the future direction is toward the more multidisciplinary observations, not only physics, but with the biogeochemical and biological parameters, or also the measurements of turbulence. Yeah, because in the last 10 years or so, there is active research on nutrient stream of the Kuroshio. So Go-san, Shinyu is one of the such, doing such. So Go-san is a better person to explain. But so it should be, the future direction is in such multidisciplinary way. Yeah.
And also including more and more stakeholders.
Thanks very much.
I'd like to have a little bit comment about the CSK2. The CSK2 is a international program, Kuroshio, international program including East Asian countries, many countries. So I like to comment about it. Thank you.
Yes, CSK2. So CSK is a cooperative study of the Kuroshio and adjacent regions. So it was an old project during I think in the 1970s. So the part 2 was just endorsed in West Park of the IOC. So with that system, the Japanese government agency can participate in such system, intergovernmental system. So we can, how to say, unify the observation system. So it might be also a good opportunity to develop our observation system.
Thanks very much. Anyone else wants to have a last comment or question before we close? No? Okay. Well, thanks very much for the presentation and the very interesting discussion. I've learned a lot. And I think the future is looking quite exciting for the region. And I'd just like to let our participants, thanks for coming. And we will have another Boundary System Task Team webinar in about a month's time on the 3rd of August, and based on the East Australian current system. So we hope to see you there, and keep well and keep safe, everybody. Bye.
Thank you very much. Thank you very much.
Thank you.
Thank you.
Thank you.